Hello and welcome back to part 5 of the Introduction to Calculus series. Today we're going to be talking about maxima and minima. Oh, that's should be minima. There we go. Excuse me for that. No, but we're going to be talking about maxima and minima. So what does that mean? Well, let's take a very basic function f of x equals x squared. If you were to graph this out like that, alright, then you'd get something like this. There we go. And we can see that this kind of has like a minimum value, right? Where the graph is lowest. It's its lowest point right here. That's what we call a minimum. A minimum. And similarly, the highest point of a graph, like that for example, here, that's its maximum. And the plural of minimum is minima, and the plural of maximum is maxima. Alright, so what we're gonna try to do is to find a way to locate these points using the tools that we built up in earlier parts. Right, so the first thing to notice is that in these special points, in these minima and maxima, the slope of the graph is actually horizontal, right? So what we can say is that the slope is actually equal to 0, because like the tangent line is horizontal, that means the slope is equal to 0. So actually, if the slope is equal to 0, then the derivative of the function f of x must be equal to 0 too. So at minima or maxima, right? Then the derivative must be equal to 0. All right. So let's try this with an example. So let's try to find the extreme values. Also, the minima and maxima are also collectively called the extreme values. Let's try to find the extreme values of, well, it's not going to be as easy as x squared. No, we'll do x cubed minus 12x, right? Well, first of all, we have to find its derivative, so let's do that. The derivative of x, derivative of f, that's going to be, well, 3x squared. This is easy enough. Don't have to do any weird chain rule or something like that. 3x squared minus 12. And to find the extreme values, we have to set this equal to 0. Alright, then we move the 12 to the other side, divide out by 3, gives us x squared equal to 4, and that gives x equal negative 2, or x equals 2. Right, and if you were to plot f of x, then you would get something along the lines of this. Excuse me, there we go, something like that. Maybe it's shifted down a bit, I don't really know. So you can see that we have both a minimum and a maximum, and I'm pretty sure that the maximum is at negative 2. We have x equal to negative 2, and the minimum is at x equals 2. Alright, and now the final thing to do, if you were to say have an assignment like find the minimum value of this function, then you would just plug in the x values that you got by solving this equation into the original function, because like the point is on the graph, right? So you'd have negative 2, and then if you were to plug this into f of x, then you'd get negative 8 minus 12 times negative 2, that's 16. So negative 2 and 16, that's one extreme value, or extremite, and the other is 8 minus 12 times 2, which is negative 16. So let's do negative 16. So those are the two extreme values, right, of this function. And I do want to highlight one more point, and that has to do with so-called saddle points. Saddle points. And that's what you get when the function kind of does the following. So you have, it goes upwards, 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 then it slows down, and then it becomes horizontal right here. Let's mark that, like there, and then it will slope upward, 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 like that. So right here, if you were to solve the equation, so if this were x, then if you were to solve the equation, the derivative of x is equal to 0, then you'd find this point, right? Because the tangent line is actually horizontal here, but it's not really an extreme value. It's what we call a saddle point. So a very basic example that I know for sure is that if you have x cubed, then you'll find a saddle point 0, 0, right? But you can find out if they're saddle points by simply plotting them in decimals or whatever you want. Right, but there is an analytic way to find out if these are saddle points or if they're minima or maxima without having to plot them, and we'll cover that in a later part. But until then, well, goodbye for now. I'll see you in the next part. Bye bye.